I'm Anil Kumar. Welcome to my series on functions. Now, this is a prerequisite course for calculus. Here is an excellent question based on rate of change. The question here is, find the rate of change in the surface area S of an optimal cylinder topped up with a hemisphere when the radius is 4 centimeters. Assume the bottom of the cylinder is included in the surface area, but the top is covered by the hemisphere. Formulas which are related are given to us. Surface area of a regular cylinder is 2 pi r square plus pi r h, and surface area of a sphere is 4 pi r square. You can always pause the video, answer the question, and then look into my suggestions. Now let's sketch the scenario. So we have a cylinder, so we can say the cylinder is kind of like this. Now when we say optimal cylinder, it means what? Now that is interesting. Optimum means that diameter is equals to height. So first thing which you should understand is what is optimal cylinder. That means diameter equals to height. So in our case, diameter is 8 units, right? Radius of 4 means diameter of 8, right? Radius of 4. So that means height will be 8. Is that part clear to you, right? So that is the very first thing which should be absolutely clear. Now it is topped by a hemisphere. So that means we have a hemisphere here on the top. So that is the hemisphere. So this surface area should not be counted as it is part of your hemisphere. Correct? It is inside. Okay, now let's write down the formula. We need to find the rate of change in surface area. So what is the surface area in this case? Surface area will be area of this cylinder, not including this but including the bottom. So in the formula, it will be pi r square, the circular area right there, plus lateral area pi r h, plus half of the sphere, right? So half of 4 pi r square. Is that clear? So that becomes your formula. So we have 2 pi r square and pi r square as 3 pi r square plus pi r h. Is that clear? So we get our formula. We combine these terms. It goes 2 times. So we have 2 pi r square and pi r square as 3 pi r square and pi r h. Perfect. So that is how we get our surface area. Now it says find the rate of change in surface area of this, right? Optimum cylinder. Optimum means we have taken height as diameter when the radius is 4 centimeters, right? So when r is equals to 4 centimeters. And clearly height will be 8. So these are the values given to us in centimeters. Correct? So now we'll find. So we'll have instantaneous rate of change of S as equal to. So in this particular formula, we'll use the value of R as 4 and we can write H as 8, correct? Which is twice R, which is twice R. So we have 3 times pi. We'll take the value 4 and 4.1. Okay, we'll keep it simple. 4 and 4.1. So first we'll take R as 4. You can write 0.1. We're just doing calculations with calculator, right? So plus pi. R here will be 4.01 times height, which is twice this. Right? So it is 8.02. So that is the surface area when it is 4.01. And from this, we'll take away minus 3 pi 4 square plus pi times 4 times 8. Is that clear? Divided by all this, divided by, we have taken 0.01, so 1 over 0.01, difference between these two. Is that clear to you? Correct? So that is how we are going to calculate it. So let me rewrite this. So what we get here is we can take pi common. So we'll calculate, we'll take pi common over 0.01, and within brackets we'll write 3 times 4.01 square, and here we have plus 4.01 times 8.02. And when you minus this, we have to minus both, right? So let me write small brackets here. Okay. We'll write minus 3 times 4 square, and we'll do minus 4 times 8. Correct? Let's use the calculator and find this. Okay. So we have 3 times 4 let's use brackets. So we have 3 within brackets 4.01 square, bracket close, plus 4.01 times 8.02 minus 3 within brackets 4 square minus 4 times 8. Correct? So let's use the calculator to find this answer. We have 3 within brackets 4.01 square, bracket close, plus 4.01 times 8.02 minus 3 times 4 square is 16 minus 32. And this will be multiplied by pi times, let's say, 3.14, and we'll divide this by 0.01. So we get equal to 125.757. Right? So centimeters. So area, so we have area on the surface area, which will be centimeters square, over the radius, which is centimeter. Correct? So that becomes our instantaneous rate of change. Now that could be rounded to approximately, let's say, 126 centimeters square per centimeter. Correct? So that is how we are going to solve this question. So I hope it makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.